Hey everybody, I thought it was a good time to kind of check in with you to see how you're doing with hypothesis testing. One of the things that I wanted to point out to you is that what we're doing now is very similar to what you've done previously, at least when we're talking about z-tests. So prior to the exam, you learned how every x-score, if you know that it's in a normal distribution, has an associated z-score, and every z-score has an associated probability, right? So you know where it is on the normal curve. What we're doing now with hypothesis testing is we're saying, okay, I'm going to give you the probability level that I'm okay with, and typically that's 0.05. So I said alpha at 0.05, that means the probability and the associated z-score that I'm interested in is associated with that 0.05. And now what I'm asking you to do is to calculate the z-test for your sampled information that you have and find out if that z is bigger than the z that's associated with 0.05. If it is, then that means that you're in the rejection region, in the critical region, and you're going to reject the null hypothesis. Remember now that a null hypothesis always predicts no difference or no effect, and that's what you want to reject, right? Because if you've conducted a study, if you've committed money and resources to developing a program or a treatment, and you give that treatment to a group of people, what you're hoping is that it's going to have some effect on them, right? So the null hypothesis, which always says there's no difference or no effect, is the one that you would like to reject. And if you can reject that null hypothesis, then you get to accept the alternative hypothesis, which is the one that you actually care about, right? So you've learned that with z-tests, and the only distinction between a z-test and a single sample t-test is that with the z-test you have the population standard deviation. And one of your classmates raised the question on one of the discussion board questions, which was, if I have both, if I have the standard deviation for the population and the standard deviation for the sample, then what should I use, a z-test or a t-test? Well, the answer is you should use the z-test, because with the z-test you have a known population standard deviation, and that's going to be more accurate than the estimated standard deviation that you're using with the t-test. Okay? So if you have both, always use the population standard deviation and use the z-test. If you only have the sample standard deviation, then by definition you've got to do the t-test. And the t-test just uses that standard deviation as an estimate of the population standard deviation. Now you've also learned about dependent samples t-tests, which means that you've got either matched pairs, which means we've matched them for something, maybe sex and age or something like that, or you've got repeated measures, a pre-test, post-test, on the same group of people. Well, if you have either of those situations, then what you do is you line up the scores that match, you subtract one from the other, and you get a new column of scores, which is your difference scores. Once you have that, you can literally throw out that original data, because now this is your sample that you're dealing with. It's a sample of difference scores. And dependent samples t-test is exactly like a single samples t-test once you take that step. Okay, now I'm telling you all this because what you're moving into next, starting really tomorrow, is independent samples t-test. An independent samples t-test is when you're comparing two samples that are independent from one another. So maybe you're comparing boys to girls, or you're comparing older adults to younger adults, or cats to dogs. They're completely independent. Conceptually what you're doing is very similar, but this is much more complicated only because you have to do an extra 2 steps to get your standard error. Okay, you have to do something called calculating the pooled standard deviation, and then you have a different formula for standard error than you've seen before. Those 2 things are complicated, but don't let them freak you out, because all they are is extra mathematical steps that you have to take for the denominator, but conceptually we're doing the same thing we've always done. Alright, so I hope that helps give you some frame of reference as we're moving forward. Hope you guys are doing well. Be sure to let me know when you're having challenges so I can try to help everybody out. Alright, good night.